Welcome to This Explainer. We're diving straight into the exact step-by-step aeronautical protocols for fuel declarations. You know, in aviation, precision isn't just a nice-to-have, it's literally a lifeline. When a pilot looks at their gauges and sees fuel levels dropping, there is absolutely zero room for hesitation or ambiguity. So today, we're going strictly by the book. We're mapping out the exact, uncompromising sequence of rules that pilots and air traffic controllers follow to prevent a disaster. We aren't adding opinions, and we certainly aren't skipping any steps. We're just looking at the definitive protocol that keeps the sky safe. Let's get right into it.
To make sure this is crystal clear, we'll follow this exact structure. First, Section 1, Types of Fuel Emergencies. Second, Section 2, Case 1, Mayday Fuel. Then Section 3, the Emergency Escalation Procedure. And finally, Section 4, Case 2, Minimum Fuel.
Okay, starting off with Section 1, Types of Fuel Emergencies. Let's get our foundational concepts locked in, right? Because before you handle a problem, you have to know exactly how the protocol classifies it.
So, under strict fuel policy, conditions are broken down into two very precise categories: Mayday fuel and minimum fuel. Now, these aren't just casual buzzwords tossed around the cockpit. They're rigid definitions that trigger completely different reactions in the sky. Understanding the hard dividing line between the two is absolutely key to grasping the entire protocol. Moving right into Section 2, Case 1, Mayday Fuel. Let's look at the parameters for the absolute highest level of urgency. The big question is, what actually defines a full-blown emergency? Well, a true fuel emergency officially exists when the calculated usable fuel on board, or FOB, drops below the final reserve. Think about what that final reserve actually represents. It's the absolute bottom line, the ultimate safety buffer that an aircraft simply cannot dig into. When the math shows a plane is going to land with less than that critical amount, it instantly shifts from a concern to a formal, undeniable emergency.
And when that usable fuel is approaching that final reserve threshold, the pilot in command has to take immediate action. They have a very strict script here. They must get on the radio and declare, "Mayday, Mayday, Mayday, fuel." That exact phrasing is non-negotiable. It cuts right through all the other radio chatter, instantly alerting everyone on the frequency to the extreme gravity of the situation. There's no room for polite requests. The protocol demands this exact declaration.
Immediately following that Mayday call, the pilot has to report three mandatory pieces of information to air traffic control. First, the actual fuel on board. Second, the remaining flight time, specifically expressed in minutes. And third, they must demand an immediate priority landing. Notice that phrasing. They aren't asking for a favor. The protocol dictates they absolutely demand it. This precise data gives ATC exactly what they need to get that plane on the ground safely. Which brings us to Section 3, the Emergency Escalation Procedure. Because, as we know, fuel emergencies rarely just happen in a split second. They build up over time. And there's a highly structured, three-step sequence of escalation that pilots have to follow as a situation degrades. It's kind of like a staircase of urgency. Step 1, the pilot first requests ATC for the expected delay. They need to know what kind of holding pattern they're dealing with. Step 2, after the aircraft is committed to land at an aerodrome, the pilot declares minimum fuel. Then, Step 3, if the situation worsens, they escalate to the final step and declare a full emergency with Mayday, Mayday, Mayday fuel. It's a rigid, uncompromising process to keep everyone totally aligned at every stage.
Now for Section 4, Case 2, Minimum Fuel. We're transitioning back to that specific case we just saw in Step 2 of the escalation process.
There's a really vital distinction we have to make here. Minimum fuel is explicitly not an emergency. And importantly, it doesn't actually grant the aircraft any traffic priority. It simply acts as a clear warning to ATC that a full-blown emergency could happen if there are further delays. Contrast that with Mayday fuel, which absolutely is an emergency that commands immediate priority. It's a brilliant distinction, really. It keeps the ATC system from getting bogged down by false alarms, while still keeping controllers perfectly in the loop about the aircraft's narrowing margins.
So, when exactly is it used? Well, the pilot declares minimum fuel when they're committed to land, and they calculate that any change to their existing clearance might result in landing with less than that final reserve we've been talking about. By making this exact declaration, the pilot is basically telling ATC, with my remaining fuel, I literally cannot accept any additional delays. This ensures they can still touch down safely before ever hitting that red line.
But of course, the protocol has to account for the unexpected. Unanticipated circumstances might mean an aircraft is going to land with less than what's required. Specifically, they might land with less than the minimum diversion fuel, which is calculated by taking the fuel needed for an alternate airport plus the final reserve. Or, depending on the route, they might have less fuel than required for an isolated aerodrome. When these completely unanticipated things happen, running these exact calculations is exactly what triggers a pilot to start the escalation procedures we just mapped out.
Now, during all of this, there's a strict separation of duties. It's a true two-way street of communication. The pilot's job is to explicitly request expected delays so they can continuously run their numbers. Meanwhile, ATC has strict, uncompromising duties too. They have to proactively advise the crew of any extra delays, and they must coordinate and pass all this vital fuel info to other ATC units when they're transferring control across sectors. It's a continuous, unbroken chain of verified information where both sides know exactly what their role is.
So as we wrap up this explainer, think about how the absolute precision of these protocols practically prevents disaster before it even starts. By enforcing this uncompromising step-by-step sequence of requests, minimums, and ultimately Mayday declarations, the system removes human guesswork entirely. It guarantees the pilot and ATC are always on the exact same page. When you're thousands of feet in the air, relying on machines and battling the elements, isn't it comforting to know that safety is mathematically guaranteed by such an uncompromising script? Thanks for joining me on this deep dive into aeronautical protocol.